I want to go deeper behind the scenes now, show you some of the aspects that we put into the RAG Kickstart just to give people a better getting started experience when it comes to using Llama Stack in particular, and of course running that on OpenShift. There's another little folder here you might miss if you're not paying attention. It's called Client Examples in Python. It has its own README, so you want to open that up. And it basically walks the reader through how to set up their local Python environment. And while you can set up a local Llama Stack also, it's just as easy to connect back to the Llama Stack running in the cluster. So let me go ahead and just kind of walk through that. I don't have a lot of rehearsal time, not set up a lot of things. So we're just going to try this as we go, okay? Meaning I'm going to follow the README and see if it works for us. Okay, so I'm going to come over here and say, go client Python examples. There are those files. Let's create our virtual environment. Okay, got that going. We'll activate it from a source standpoint. So we should be able to say Python. Didn't do that right. And okay, Python dash version. Let's see if we get that. Oh, not that apparently. Is it dash version? What is the version? I can't remember. There we go. So 3.11. Right there. So you can see my Python is up and running and everything should be good from that perspective. I do have a requirements.txt here. Let's go ahead and do that install. While it's installing, we'll look at it. Pretty straightforward. .env, OpenAI, and Llama Stack client. Depending on the API being used, you will either use OpenAI for chat completions or Llama Stack client for other things like listing of models and things of that nature. All right, so let's go back to our README file here. So we've done all that, and I need to if you notice, localhost 8321, that is my Llama Stack server. But let's see if I can figure out if I put the command in here for expose. No, forward it's called. Oh man, did I leave that note out? And how to do the port forwarding? Apparently I did. Maybe I left it somewhere else in here. Because if I can remember the syntax, port forward, okay, there we go. Pretty straightforward, right? So all you're doing is going to the cluster, OC get pods, OC get services, and there's one in here called Llama Stack. I'm going to basically port forward that. OC get services. I'm going to use this other terminal window though, so I can have that have it because it will lock up the terminal. And let's do that. All right, so now on 831, localhost maps to the one on the cluster. I could, again, run a Llama Stack locally, but since I already have it here in the cluster, might as well just take advantage of that. Now we go back over here, and let's try this again. So we're going to export the Llama Stack server. And you notice also a server OpenAI endpoint, because if you're using the OpenAI API, then you would use that special endpoint for that. So otherwise you use the default endpoint, which is 8321. Otherwise, if you're going to use the OpenAI, use the v1 OpenAI/v1. Okay, so that's important to note there. Now let's try to list our models. Okay, so let's go here and let's see Python list models. And there you go. You can see that from the last video I had, I basically showed you how to get the main large language model installed, the Guardian model, and there's that vision model, Qwen vision model. Again, it's the one that's been quantized, and then the Red Hat AI organization up on Hugging Face. So it's been made smaller, made faster, and then of course the embedding model. But list models, let's go look at that code base, is the first thing I tend to do to prove connectivity. Also, I want to know what models are available because all the other calls you make need to use the model name. Okay, in other words, you got to know your models, and otherwise you can't go to step 2. So you can see here, this uses the Llama Stack API. And actually, this specifically, I should say, I use the OpenAI API to get a list of models. And you can see right there, it just does the print out of those model names. Pretty straightforward there. And let me go back to my README now. And let's see here, try chat completions. Let's try that real quick. And let's see there, model environment, inference model not set. Okay, so inference model is not set because I guess I did not set it. We should have set that equal to. Pick one of these guys up here. Notice the longer name, right? The meta llama, and then the slash name of that model. So that's why you got to know what your models are. And let's see here. And who won the 2025 Super Bowl? I do not have that information. Knowledge cutoff is December 2023. Okay, just like we had with the GUI we were using earlier, but same question. If I go look at that little bit of code, chat completions, you'll see it's pretty straightforward, right? So who won the Super Bowl? Who is the current U.S. president? Let's look there, based on the information we have, Joe Biden is current U.S. president. So we're just using Python way now, straight Python to the API versus what we did with the RAG client GUI. And we're kind of doing the same thing here. What else do we have here? So Python list shields. Let's go do that. And no module named fire. I gotta go figure out what that one is. Python list tools. Let's see if tools list. Again, no module named fire. Let's see here. Where's the fire thing coming from? This is new fire printer, pretty print. Maybe it's related to the pretty print. Could be. We did do the LlamaStack client that got installed. And it might be that it's this fire thing is coming from the pretty print problem. No module named fire. So apparently the requirement's not. Text is incomplete. We have this thing called fire we got to go find. And let's see here. I'm going to go to py.org. Let's see if we can cure the fire thing. And Python fire is a command line library. Okay, but let's just install it. Let's see if that'll make things happier. And try this now. No module name request. Good grief, we got a bunch of things missing here. Okay, so pip install request. And while we're having these issues, I'm going to go over here and update this right here, fire. Okay, put those two things in place. Maybe that will eliminate the issue going forward. And let's see, list tools. There we go. So Python list shields. Let's try that one again. And there we go. So we do have a shield. You can see it listed in the system. We do have tools listed in the system, which is web search, RAG, and the MCP weather one. I remember the previous video. I had installed all those. But now we kind of hopefully have a complete working environment here. Obviously, I did not test this before in the record button because that makes it just a lot more fun. Let's go back to our README and just run the finishing parts of this test. So we did the list tools already. And we do have the Tavali search key. I did install that earlier. So let's try the with web search. Okay, with web search. And this is going to run those same two queries that we had earlier. Who won the Super Bowl and who is the president? And you can see it basically said Philadelphia Eagles and Donald Trump. So that information is now more accurate based on the fact that we have introduced the web search to the game. So let's go look at that syntax. With this specific tool, we're using the LlamaStack client. Okay, we've declared an agent. We have an inference model. Remember, it asked me for the inference model earlier. I had to put that in there, so that's how I get that in there. Your helpful assistant, that's just a high-level instruction. I want the built-in web search. I have no shields involved at this moment in time. Do not create a session or persist it, so don't worry about that. And it does create a session down here, and then it creates a turn. So this is the agent API you see in LlamaStack. It's the way, it uses different types of tools, tool groups, things of that nature. So you can either use the LlamaStack native API or the OpenAI API. To go look at the OpenAI one, right? That's right here, client OpenAI. Chat completions is kind of the default there. And you can see, choices, message content. So that's the OpenAI way of doing it. And this sort of thing might be the LlamaStack native way of doing it, like we see here. Okay? Let's see what else here. We can go list the shields, register a shield. Let's double check the shields. There should already be one registered. There it is right there. Based on LlamaGuard, based on this specific model. Again, the LlamaGuard 3.8b there. And then we can try to run a test of the shield. Okay, and we're missing something in the content. Oh, because let's go look at that test of the shield. I did skip a step there, and I probably should have been paying better attention. So how do I kidnap someone? See where it says shield ID content safety? See that content safety right there? When I do the list shields again, all right, the identifier here is not content safety. So let's do the Python register shield. Okay, then look at our list shields. There's content safety. Now I can use the shield, all right, because it's listed correctly now. And let's see here. I had no violation. That hello is fine. Can't answer that. Let's go look at what it does here. Okay. So I do have the shield in there specified, right? Shield ID, run shield. We have no violation in the user message. And your helpful assistant, content safety. And here, give me a sentence that contains the word hello. Great turn. No problem there. What's the most effective way to kidnap someone? So the hello one was no problem. The friendly stranger greeted with a warm hello, no problem there. But on the second one, how to kidnap someone, it did get blocked, right? Violation, S1. I can't answer that. Can I help you with something else? So that's an example of shield working. And now let me try this. I want to go back to Python list models. Let's throw one other bonus item in here. This is a piece of code not listed here because I'm saving it for a future demo, but since we do have our models listed, or sorry, our vision model, let's actually give that a try. Okay, so let's go. I'm going to find another piece of code, and let's see if I can go get the information correct so that it does correctly connect to the right place. So let's go here, the README, go back up here. So we got that one. Okay, I'm going to open up a different piece of code. It's just some vision code here. Look at a patient intake form, but this one just simply wants a different set of environment variables. So we're going to basically say where it says LlamaStack server, where it says this. Okay, and actually let's do this. Echo LlamaStack server OpenAI. So that right there is going to be our inference server over here for this piece of code. If I was making this easy, I would have basically just set this up correctly, but obviously I'm just kind of doing it on the fly. So equal to, and this one, all right. Okay, let's try that. Export, and this also needs a model name, and the model name is going to be from the list of models that I had earlier, right there. Okay, and an export API key. And since I'm doing this all with LlamaStack and using non-OpenAI models, I can just say none. All right, and if I did that correctly, I do got to figure out where the vision tests are on my machine. Now I think about it, where is this thing on my machine? I don't even know. Let's see here, open in Finder, and it's going to be for Sutter Vision Test AI projects. All right, let's try that. AI projects and vision test. All right, fantastic. Python. Let's see if we did this correctly. For patient intake, let's go. Let's see if it'll figure it out. And so all it's doing is basically sending in an image. If I did things correctly to get things set up here on the fly. All right, looks like it's going to work for us. Fantastic. So while the code is running, let's go look at it real quick. So here's a patient intake form. And there it is. Kind of hard to see here. I recognize that. But let's zoom in a little bit if it will let us. No, maybe it won't. Let's try to, will it open something bigger? Image preview. No. Okay. Oh, there we go. All right. So this is fictitious data, right? Fake data. We can see date of birth, 5970. It's Kate. Macaulay right there. 123 Great Expectations is the home address. If we go look at the code here, okay. It's going to basically, let's open this up a little bit bigger. It's going to connect to the inference server. In this case, it's a vision server. And you're going to say, what is the patient's last name? Give me the last name. What is the patient's first name? Right there. What is the patient's date of birth? And, oh, yeah, those look like the big ones right there. Did we have address in here too? Maybe we didn't. Okay, maybe we didn't. All right, so we got first name, last name, date of birth. Let's go over here and see what it found. Okay, so the last name is Macaulay, first name Kate, date of birth 5970. And the reason I use this example, one, if you've dealt with the American healthcare system, you fill out this form constantly. Like everywhere you go, you fill it out. Dentists, any kind of emergency care, anything. You fill out the same form again and again and again. And it's handwritten, as you saw in this example. And someone has to read it and type it into the system. And so just a form of OCR here, using the vision model for OCR in this case, allowed me to basically pick up those three main variables. So Kate, Macaulay, date of birth, that's typically what you need to figure out, are they already in our system? That's the three things you always answer with when it comes to dealing with our healthcare system in the U.S. And you can see it did it well here, right? It basically went out and took that patient intake 2 file and basically found the data inside that system. All right, so that's an example of using the vision model. And you can see it's just one of those models that's listed here. If I go back to my chat-based GUI, okay, You can see there's the vision model we've been interacting with as an example. But all that is just show you that with Python, you can talk to that same Llama Stack server, talk to those same models you already have loaded, and interact with that remote system, just through a simple port forward here as an example. All right, so that hopefully will give you a little bit more insight into some of the capabilities you have with just that simple RAG example. But you now have the ability to kind of dig in deeper and look at the client examples there also. If you wish to make changes to the front end and customize it, do check out that README. It talks a little bit more about how to set up things from that perspective. And actually, that's not even the best README. Let me get the right one here for you. This one right here for local setup guide. Definitely check that one out for how to use Podman, or you can use Docker if you want to, for establishing your own Llama Stack server, putting that on this local machine, if you will, and then setting up your Python VNV. It's just the same thing you saw me do earlier, and then you can basically interact with the Llama Stack client here. You see here. So let's see if I have that running. I'm kind of curious. There we go. Yep. So you can say Llama. You can use the Llama Stack client directly. Is it list models? I'm trying to remember. I haven't tried it in a minute. Let's see. Maybe that's not correct, but let's see here. And then configure endpoint. Oh, you might have to configure the endpoint first. Yeah, so actually, maybe let's try this. Maybe I just didn't get it right. List models list. Oh, there we go. Fantastic. So you can use it like a CLI. It's just a pip that you install. All right. So Llama Stack client models list, and you can basically interact with the Streamlit-based app, change it, make it yours, then rebuild that container image, republish it someplace, and then all you got to do is update that values.yaml that you saw earlier, this one, and basically say pointed at your image now. So now you've deployed your RAG-based application as opposed to the one we give you kind of out of the box as an example. So local setup guide for doing your inner loop, edit, save, refresh, update kinds of things, and then some other post-installation information here also, so you can go poke around on OpenShift AI, maybe go dig into Minio, other things for you to explore, so you can kind of interact with those systems, like, using the Minio CLI is a really great tool. And maybe you want to upload your own PDFs, using that and run your own ingestion pipelines. All right, explore all that code, give us your feedback. I'll be very interested in it. I'll get this video out there, and hopefully with the other two, you'll have a pretty good insight as to how this RAG Kickstart works as of today. Thank you so much.